Hello out there, welcome to this tutorial on transformations. In this video, we'll be looking at reflections. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on transformations. So we start with definition. Reflection is flipping an object to form a mirror image over the mirror line or reflection line or line of symmetry. We look at the diagram below. Here, if this is the object, this is the image, we call this the mirror line or reflection line or line of symmetry. So this object is flipped over to form this image. At every point, this mirror line is the line of reference. As it is called line of symmetry, it is a midway of every point from the object to the image. Like for instance, the farthest point is this vertex and this. If you count 1, 2, 3, that is 3 units from the mirror line. Also for the image, we count 1, 2, 3 units from the mirror line. The same thing here. This vertex here is 1 unit. This is also 1 unit. So also this. So we will now go further to solve some problems on reflections. So we start with problem 1. For problem 1, in the diagram, show the reflection of the triangle in the mirror line x is equal to 4. So you can see this is the mirror line which has been drawn for us. X is equal to 4. If the mirror line is not drawn, you have to draw it. And as we stated earlier, if we start from here, which means the height of the right angle triangle is 1 unit away from the mirror line. You can see this is from here to this is 1 unit, from here to this is 1 unit. So if we start from the height of the image, so which means we are going to start from here and it comes down to this point. So we have it as starting from here down to this point, and you can see now, and the base which is 3 units, we also start from here, we count 3 units, 1, 2, 3. So the base is going to be from here to this point. So we have it drawn. Then we can now join from this point to this point, and we have this as the image while this still remain the object. So we are done with problem 1. We then go to problem 2. For problem 2, in the diagram, show the reflection of the triangle in the mirror line x is equal to 3. So we have been given the mirror line as x equal to 3, and we are to reflect the triangle. As you can see, there is no distance from this vertex from the mirror line, which means the image is also going to start from here and we then move 3 units to the right. So we have the base here and the height is going to be 1, 2, 3 units also. It's 3 units upward, then you now join. This is isosceles right angle triangle. Yeah, isosceles right angle triangle. Since this is 3 units, this is 3 units, and this is right angle. So this will still remain the object while this is the image. So we have done justice to problem 2. We then go to problem 3. For problem 3, in the diagram, show the reflection of the triangle in the mirror line y equal to 4. So we have been given the mirror line y equal to 4. So now if we take this as the base is parallel to the mirror line. and it is 1 unit away. So we are going to have the image to have its base from here to this point. So we have it on line y equal to 3. Now we go to this vertex, we mark it. This is 1, 2, 3. It is 3 units away from the mirror line. So we are going to count also from the mirror line 3 units. 1, 2, 3. So we have it at this point. We now join it to this line. We then join from this point to the other end of the base to get our image. While this still remains the object, this is the image after reflection in the mirror line y equal to 4. And that is all for problem 3. We then go to problem 4. For problem 4, draw the reflection of the image in the mirror line and give the equation of the mirror line. Here, remember, we are flipping. If this is flipped, look at it. Along this line, if it is flipped, this base will become this, and this will be going this direction. So you can see that if it is flipped. Now, looking at the mirror line, the image has one of its vertices on the mirror line, so automatically the image will have its vertices or one of its vertices on the mirror line. And for your information, it cannot come down this side. Let's call it height. The height cannot go down because if it is flipped, you see it is coming to this side and this guy is coming down. So we now count 1, 2, 3, 3 units. So which means we are going to count 1, 2, 3. So we now draw. This base now becomes the height here. So we have it drawn, which is 3 units. Then this one now will be going this way. How many units? 1, 2, 3, 4, 5 units. So 1, 2, 3, 4, 5. So it will be from here up till x equal to -4. Then we know the other dimensions now. So this is 1 unit. So this comes here to join this. While this we move up, we close the shape. This is still the object, while this is the image after flipping or reflection in the mirror line given. We are done with the first part of the question. Now we are to give the equation of the mirror line. So to get the equation of the mirror line, we are going to list out some points along the mirror line. So we can pick -3, 3. This is the point we have picked. -3, 3. Here is going to be -2, 2. So we have it there. -1, 1. We have -1, 1. It passes through the origin, so we have 0, 0. And here is 1, -1. And here 2, -2, and so on. So from here now we'll be able to get our equation of the mirror line. If you look at it now, they are negative of each other. This is x, -3, y 3, the same thing here. So we can then go ahead to get the equation of the mirror line, which is going to be y equal to -x. Since if y is 3, x is going to be -3 as it is contained here. When x is 2, it is going to be -x, which is -2. So that is that for problem 4. I hope you are following, you are getting it. Thank you. So we go to problem 5. For problem 5, draw the reflection of the image in the mirror line and give the equation of the mirror line. And if you can see now, this is taking the different direction, the mirror line. The previous problem, which is problem 4, was going this way, but this one is going this way. In the same way, if it is flipped to this side, this height here will become the base here. So we're going to have the image to have its base here, and the height will be going up. The height cannot go this way, so it can only go this way, so that when flipped, move to the other side, this angle 90 here will lap with this, and this top will lap with this. So we now join to have our image here, while this still remain the object. Now, to get the equation of the mirror line, we still list out some of the points along the mirror line. This is not the same thing with x is equal to a constant or y is equal to a constant. This is not the same. So doing that, so we pick any of these points starting from here. So if you pick -3, -3, here is -2, -2, -1, -1. So it passes through the origin 0, 0. This is 1, 1, 2, 2, and so on. And if you look at it now, they are equal. X is equal to y. So the equation of the mirror line is y equal to x. And that's all for problem 5. We then go to problem 6. For problem 6, in each diagram, describe fully the single transformation that maps diagram A onto B. So we have 2 diagrams here, labeled A and B. So starting from problem A, we need to see what type of transformation is this first. And since A is mapped onto B, if you look at it now, it's a flipping process. If this is flipped to this side, it will lap with B. So the transformation is reflection. And now to get the mirror line now, we now find the line of symmetry of this kite. This is a kite now. The two shapes combine and sharing common base is giving us a kite. And that's their common base is the line of symmetry, and the equation of line of symmetry now is y equal to 4. And that is that for problem 6a. Then we go for B. For B also, if you look at this now, this is the image, this is the object, and it's very clear now that this is the image. We can now say the type of transformation is a reflection. Now we go ahead to find the equation of the mirror line to fully describe the transformation. Since it is a reflection, it must go with the mirror line, or line of symmetry, or line of reflection. Now if you look at the two objects, you see that this y-axis is perfectly separating the distance between them. This is from y-axis to object A, we have 1 unit. From y-axis to object B, you have 1 unit. So that line is the mirror line, and it is x equal to 0. That is the equation of the mirror line for reflection as represented in problem 6b. So with this, we have done justice to problem 6. We then go to problem 7. For problem 7, A, plot and join the points -2, 0, 2, 3, 0, 4, and negative 4, 1. B. Give the mathematical name of the shape. C. Reflect the shape in the mirror line y equal to x minus 1. D. Give the coordinates of the reflected points. E. Reflect the point negative 4, 1 in the mirror line x is equal to negative 1. So we start from A. We have to plot the point negative 2, 0, negative 2, 0. This is the point here. It is marked out. And 2, 3. This is 2, 3. This is the point here. And 0, 4. 0 is the y-axis. And 4 at that point is the point. Negative 4, 1. This is negative 4 going up. This is 1. Then we join the 4 points. So we join this to this, this to this, this to this, and this to this. So we have plotted and joined the points, and B, and that is A. For B, we have to give the mathematical name of the shape. This is a parallelogram. So the shape is parallelogram. Then C, reflect the shape in the mirror line y equal to x minus 1. Y equal to x minus 1. Remember, y equal to x is passing through the origin this direction. Y equal to negative x is this direction. Now we have y equal to x minus 1, which is still a straight line but not passing through the origin. So we just create 2 points. The mirror line is y equal to x minus 1. We are going to generate 2 points to enable us draw the straight line. Here we make x equal to 0, y will be negative 1. If we make y equal to 0, x will be 1. So the 2 points now are 0, negative 1. When x is 0, y is negative 1. And 1, 0, because when y is 0, x is 1. So we plot the 2 points and join to get the mirror line. So when x is 0, y is negative 1. X is equal to 0 is on y-axis, negative 1 is this point. And when x is 1, y is 0. When y is 0 is the x-axis, and x is 1 there. So we mark it out and join the 2 points. So we join the 2 points. This is the mirror line that we're going to use to reflect this shape. So we take a point. The first vertex here is 2 units. Okay, no, since it is slant, it can't go straight. It cannot go straight. It's not going straight. No, because if it is flipped, if it goes straight and if it's slipped, it's not going to lap, since this line here is not parallel to this. So they are not parallel. So has it been they are parallel, then we can now use this. So let's look at this. From here to this point is 1.5 units. So meaning if we get 1.5 units, also here we are going to have this point. And if you look at this now, it is cutting or sloping along 2 squares. Remember, it's from here, it goes to this point. That's 1.5 units. So from here now, which is half, and this is half, our line is starting from here and it's going to form a diagonal for the 2 squares combined as rectangle. So we have it there. Then we'll move to the other vertex of the parallelogram. For your information, it's going this way, the line is going this way, and basically we are considering this vertex here. This is going to be 1 unit, that is the diagonal of this square, which is also going to be the diagonal of this square, and it goes to form the diagonal of this rectangle that combines these two squares. So we have the opposite side of the parallelogram to be this. We then join the points to form the image. So we join from here to this place, and also from here to this place is joined. This is the image of the object after a reflection in the mirror line y equal to x minus 1. So we are done with C part of the problem. So from here now we go to D. Give the coordinates of the reflected points. The first point here is going to be 1, -3. So we have 1, -3. So we go to the next point. Remember, it must go in corresponding order. This is corresponding to this, corresponding to this, and this. So we come to this vertex. This is going to give us 4, 1. So we have the next point as 4, 1. This one is going to be 5, -1. So we have 5, -1. And the last one is 2, -5. So we have it as 2, -5. So we are done with D. So we go to E. For E, reflect the point -4, 1 in the mirror line x is equal to -1. We start from the mirror line, which is x equal to -1. This is x is 0, x is -1 is here, so this is the mirror line here. This is the mirror line, and the point to be reflected is -4, 1. -4, 1 is one of the vertices of the parallelogram, so we mark it out. How many units away from the mirror line? 1, 2, 3. So 3. So see, following that line, we count 1, 2, 3. So this is the point. This is the image point after the reflection of the point -4, 1, and the coordinate is 2, 1. So the image is 2, 1. And that is all for problem 7. This is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Remember to subscribe to our YouTube channel if you have not done that. Also check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on transformations. Until we come your way again, goodbye.